This video is the next video in the simultaneous equations set of video. In particular, this video is looking at solving simultaneous equations algebraically. And in particular, this is looking at type 1 of the solving simultaneous equations algebraically. So when we solve simultaneous equations, we can do it in two ways. We can either do it graphically or we can do it algebraically using algebra. We've already looked at the graphical method, so that's the one where we were graphing out the lines and we were finding the point where they intersect. Now we're going to be able to use algebra to figure out where the point of intersection of two equations are. There's various ways you can do this, but we're going to use the elimination method to solve simultaneous equations. And it's the only method we're going to look at for solving simultaneous equations algebraically. There is 5 steps for solving simultaneous equations algebraically. The first one is you make the number of y's equal in both equations. Then you make sure that the sign in front of y are different, and to ensure the signs in front of y are different, you multiply one of the equations by -1 if they are the same. Then you eliminate the y value, which is why it's called the elimination method. You solve the equation for x, then you sub the x value back into the first equation to find the y value. Now, that doesn't make too much sense if I don't go through an example with you. So on the next few slides, I'm going to go through how we do it. Today, in this video, we're looking at type 1. And type 1 are solving simultaneous equations such as the two examples there. And what I mean by that is neither equation needs to be changed. So, the best way to describe how to figure out this and how to do it is by going through a few examples. Here I have the simultaneous equation, which is 3x plus 2y equals 16 and 2x minus 2y is equal to 4. Now, the steps that we have, step 1 is all about making the number in front of y the same. So we're making y's the same. So here we have to look at the y and we see if the number in front of y is the same. We're not worried about the sign, just the number. And you can see we have 3x plus 2y is equal to 16 and 2x minus 2y is equal to 4. So there's a 2 in front of both of those. So step 1 is done for us already. Step 2 talks about the sign in front of y and we need a different sign. So what we need to do is we need to look at the y and we need to look at the sign in front of the y's and see if the sign is different or the same. So here we have plus 2y on the top and minus 2y on the bottom. So are the signs different? The signs are different. So that's step 2 and step 1 done. Step 3 then says eliminate y. And we're able to do that if you put a line under the second equation and you add the two equations together. So we have 3x plus 2x, which will give us 5x. And we have 2y minus 2y. And 2y minus 2y will eliminate because it gives us 0y. So we don't write that down. And that's equal to 16 plus 4. And 16 plus 4 is 20. Next then, we need to figure out what x is by itself. So step 4 is find x. Here we have 5x is equal to 20. So to get x by itself, we divide both sides by 5. When we divide both sides by 5, we get x is equal to 4. So that's step 3 and step 4 done. Then step 5 is find y. And how we find y is, well, we now know that x is equal to 4. So we take one of the equations from the start, and only one. So I'm going to take the top equation, which is 3x plus 2y equals 16. Now, you could have taken the bottom equation, completely up to you which equation you take. But I took the top equation. And you put your answer, which is x equal to 4, into the equation. So this becomes 3 times 4 plus 2y is equal to 16. So we get 3 times 4, which is 12, plus 2y is equal to 16. What we need then is we need the y on the left and the numbers on the right. So I'm going to minus 12 from both sides. We'll be left with 2y is equal to 16, take 12, which gives us 4. We need y by itself then, so we divide both sides by 2. and we get that y is equal to 2. So the point of intersection of this simultaneous equations is 4, 2. Example 2 is very similar to example 1. So it has the simultaneous equation 4x plus 3y equals 32 and x plus 3y equals 17. Now I'm going to add in here the steps how to solve a simultaneous equation. Step 1 is we make the number of y's equal in both equations. So if we look at the two equations we have here, we have 4x plus 3y is equal to 32 and x plus 3y is equal to 17. So if we check the y's, we have 3y and 3y. So we need to make the number of y's equal. So the number of y's are already equal in this question. So we can put a tick beside step 1 because step 1 is done. Step 2 then says, if necessary, multiply each term in the second equation by -1 to ensure the number of y's have a different sign. So we need to have the signs in front of y different. So here we have plus 3y and plus 3y. So here the numbers are the same, so we multiply the second line by -1. So what we'll be left with is the first line stays the exact same, so we have 4x plus 3y is equal to 32, and the second line is multiplied by -1. So we're left with minus x minus 3y is equal to -17. Now we can check again, so now the signs in front of y have to be different. And here we have a plus 3y and a minus 3y. So the signs are different, so we can put a tick beside step 2. Making sure that you remember that we have to multiply the entire line by -1. Not just the y term, but the entire line by -1. Then, if both of them are correct, what we can do is we can put a line underneath the simultaneous equation and eliminate the y term. So we have 4x minus x, which will give us 3x, and 3y minus 3y, which will eliminate and give us 0y, so we don't need to write that. And then we have 32 minus 17, which will give us 15. We then know that 3x is equal to 15. We need to figure out what x is, so we divide both sides by 3. And we get that x is equal to 15 divided by 3, which is 5. Then we've eliminated the y value in step 3 and we've solved to get the x value in step 4, which is completely correct. Then we take the equation, either one, it doesn't matter which one, and we sub in x is equal to 5. So I'm going to take the second equation this time, and what we have is we have x plus 3y is equal to 17. Again, I'm going to replace x with 5. So what I'll be left with here is I'll be left with 5 plus 3y is equal to 17. What I'm going to do then is I'm going to get the y on the left and all the numbers on the right. So I'm going to minus 5 from both sides. I'll be left with 3y is equal to 17 minus 5, which gives us 12. To get y by itself, I divide both sides by 3, and I get that y is equal to 4. So the point of intersection of these two lines is 5, 4. Question 3 is very similar again, so I'm going to add in the rules for solving the simultaneous equations. Again, we're going to follow these 5 steps for solving the simultaneous equation. Here we have the simultaneous equation 5x plus 3y is equal to 9 and 2x minus 3y is equal to 12. Firstly, we're going to make the number of y's equal in both equations. So we need to have a look at both equations and see if the number in front of y are the same. So we have plus 3y in the first equation and minus 3y in the second equation. So we can see that the number in front of y is the same in both equations. So that's step 1, already done for us. Step 2 says, if necessary, multiply each term in the second equation by -1 to ensure that the number of y's have different signs. Here we have plus 3y and minus y. So we have a plus in the first one and a minus in the second one. So the signs are different, so we're happy now. Then we put a line under both equations and we eliminate the y value. So we go 5x plus 2x, which will give us 7x. And we have 3y minus 3y, which we can eliminate because that will give us 0y. Finally then, we have 9 plus 12, which will give us 21. Then we have 7x is equal to 21, and what we need to do in step 4 is we need to solve the equation for x. So we have 7x, we need to figure out what x is, so we divide both sides by 7, and we'll get x is equal to 3. Then we must do step 5, and step 5 says sub the x value back into the first equation to find the value of y. So we can either pick the first equation or the second equation, it doesn't matter, you can decide. I'm going to pick the first equation, which is 5x plus 3y is equal to 9, and we replace the x with 5. So we get 5 times 3, which is 15, plus 3y is equal to 9. We can then take 15 from both sides, and we'll be left with 3y is equal to 9 take 15, which is going to give us minus 6. Then we need to get y by itself, so we can divide both sides by 3, and we'll be left that y is equal to minus 6 divided by 3, which is minus 2. The point then where these simultaneous equations intersect is 3 minus 2. The questions you're going to be doing are on the screen now. These questions are very similar to the 3 examples I have gone through, so you should have no problem with doing any of these questions. They should hopefully be easy enough for you to complete. If you do have any questions, get in contact with me straight away and I'll go through anything that doesn't make sense. But I'm hoping after watching this video and taking down the examples that these questions will be much easier.